Welcome back to the deep dive. Think about the last time, maybe even this morning, you were just, really frustrated with your computer.
Uh-huh.
That feeling, perhaps, when you spent 10 minutes watching that little spinning icon while Windows installed some mandatory update you definitely didn't ask for.
Oh, yeah. Or the sudden, jet engine sound when your laptop fans just roar to life because you dared to open a second browser tab.
Exactly. It often feels like we're kind of caring for this complicated, demanding pet rather than just using a tool, doesn't it?
It really does. And today we're going right at the heart of that, challenging the very foundation of that whole experience. We've got this fantastic stack of source material here. It's compiled by someone with, get this, over 3 decades of real, practical, hands-on experience in IT programmer, system administrator. The person who's actually fielded those, why is my computer so slow, calls for years and years.
So they're not just venting. This isn't just complaining.
Not at all. They're presenting a really detailed, quite radical indictment of the whole modern personal computer model.
Okay, so our mission today then, using this deep industry insight, is to figure out if the computer you're probably using right now, that powerful machine, is actually, is it an overkill monstrosity for the average person?
Right.
And maybe more importantly, explore why the only logical path forward, economically, practically, might be this big shift towards cloud computing or the thin client model.
Okay, let's unpack this as you said. The core conclusion from this source material is pretty blunt. Shockingly blunt, actually.
Go on.
Today's standard PCs, doesn't matter if it's Windows, Mac OS, Android, even Linux they are, the argument goes, fundamentally flawed for most people.
Flawed how?
They're designed for yesterday's problems, essentially. So the result is they're way too complicated. They rely on unnecessarily heavy hardware. They need constant maintenance.
The updates, the fixes.
Exactly. They guzzle power. And because of all that, they're just too expensive for the person who basically wants to check their email and maybe watch some Netflix.
So the paradox here, the thing we need to get our heads around, is that these super powerful machines we all chase might actually be holding us back. A detriment.
That's the core idea we need to explore. It's completely counterintuitive, isn't it?
Totally. We're always told faster is better, more power is better. But let's dig into why this complexity is baked in. Let's start with what the source calls the curse of the fat client model. What does fat client actually mean? Why is it the villain here?
Right. So fat client, it's essentially the traditional computer you're probably picturing. The key thing, the definition, is that the critical applications, your Word, your Adobe software, those big game files, whatever, they live entirely on the computer itself.
Okay, so installed locally on the hard drive.
Exactly. Locally stored, locally installed, locally executed. That's the fat part. It's the opposite of a thin client, where the application actually lives somewhere else on a server and is delivered over the network.
Got it. So because the application lives and breathes and needs updating on your machine, that's where the trouble starts for the user. You mentioned wrestling a bear earlier. That feeling of just sitting there watching the Windows spinner. That's the real human cost of this fat client thing.
That's precisely it. This local storage model, it's the root cause of this huge management and maintenance burden. For, the average person at home, the pain is constant. Every single piece of software needs to be individually installed.
Right, and configured, maybe registered.
Registered and then constantly updated, patched. The source, drawing on that long career, points out this complexity is behind endless daily troubleshooting for typical non-technical users.
Because when something goes wrong, a driver clash, a corrupted file, a bad update.
Yeah, anything.
Yeah.
The user has no simple fix because the whole system is designed for local management, which needs this ever-growing technical know-how that most people just don't have or want.
Okay, so it's a hassle at home. But scale that up. Think about businesses. The source talks about the economic side of this for big organizations.
Oh, it's staggering. Absolutely staggering. Imagine a huge company trying to keep all its computers consistent. They specifically mention the nightmare of updating something common, like Microsoft 365, across the whole enterprise.
Thousands of computers, maybe?
Tens of thousands, sometimes. It requires this immense, constant, and incredibly expensive effort. You're not just paying for the software license. You're paying for an army of IT staff, sometimes hundreds of people.
Just to manage the software.
Their entire job is deploying, patching, troubleshooting, and managing those local installations on every single computer. It's the absolute definition of operational overhead. Maintaining the same application on thousands of separate machines is just exponentially more expensive than managing it once, centrally.
So the big cost isn't necessarily buying the computers in the first place.
Not primarily. Oh.
It's the ongoing administration burden that comes directly from having everything duplicated locally, the fat client model itself.
Exactly. The system is inherently inefficient. Every single computer is its own little complex world that needs constant specialist babysitting.
Okay, downsides established. Massive downsides, really. But let's be fair, there has to be a reason we ended up here. What's the one big, undeniable advantage of the fat client? Why did it become the standard?
There is one key reason, one sort of saving grace, the sheer local computing power and graphics capability it offers.
Right, raw horsepower.
Phenomenal processing power right there on your desk, dedicated just to your task. If you need to render a complex 3D animation or do high-speed video editing, run huge calculations on local datasets, play a visually demanding video game.
Things that need instant access to the CPU, the graphics card.
Absolutely.
Yeah.
Tasks demanding that super low latency access to the processor and the GPU. For those tasks, you really do need that local, raw, dedicated power right where you are, no question.
Okay, so we acknowledge that. Raw power is the upside. But that brings us right to the pivot point the source makes. Is that incredible power actually necessary for most of us? Which leads us into section 2, the overkill argument. Let's look at what average people actually do with their computers.
Yeah, we need to ground this in reality. When this IT veteran listed out the common activities, a really clear pattern emerges. It separates the professional power user from pretty much everyone else.
Okay, the source breaks it down. First category, communication. That's things like webmail, right? Hotmail, Gmail, maybe Outlook through a web browser for work.
An entirely browser-based, yes. All happening online.
Then social media, Facebook, Twitter, Instagram, again, mostly in a browser or a simple app connecting to the cloud.
Correct. All accessing cloud services. Next up, media consumption.
Streaming music like Spotify, watching Netflix, reading news online.
Exactly. These are just data streams your computer displays. All the hard work, the processing, happens on their servers, not on your machine. And the last big one is life management.
Like online banking, shopping, booking holidays, managing appointments.
Every single one of those tasks is just accessing a standard website through your browser.
So if you just tally up that list, It's pretty obvious, isn't it? The vast, overwhelming majority of everyday computer use is purely internet-based.
It happens inside a browser or window. And a browser is fundamentally just a thin client interface. It's designed to display remote information.
Okay, but what about the exceptions, like actually creating stuff? The source mentions text processing, making presentations.
Right. And historically, yeah, that meant you needed Microsoft Word or PowerPoint installed locally. Heavy programs.
But things have changed, haven't they?
Massively. The source points out, and it's true, that web apps like Google Docs or even Microsoft's own online versions of Word and PowerPoint prove definitively you can do these tasks perfectly well online now.
With just a browser.
With just a browser. The capabilities of these cloud suites are easily good enough for, I'd say, 90% of what students or office workers need to do.
So when you put all that together, the conclusion seems almost unavoidable.
It really is. Nearly everything the average user does can be handled perfectly well with just two things. A decent web browser and a stable internet connection.
Which
means that heavy, complex, fat client computer, the one that makes you wait, the one that needs constant fixing, it's massive overkill. It's a professional tool designed for heavy lifting.
But it's being bought and maintained by people who are basically just using it as a very fancy, very expensive window onto the internet.
Precisely. An expensive digital window.
And we pay a price for that unnecessary power, don't we? Both financially and, well, physically. Let's talk about the actual hardware bits the average user is forced to buy and maintain, but doesn't really need.
Okay, start with the operating system itself. Windows, Mac OS. You're paying for this massive multi-gigabyte OS. It needs huge resources, takes ages to start up just to load all its background stuff.
Before you even open a browser.
Right, then the hardware. You're buying an expensive multi-core processor built for serious number crunching. That chip needs a big, heavy power supply. You need lots of RAM, often 16 gigs or more now, and very often a fast, dedicated video card.
Let's linger on that video card. You mentioned earlier it's kind of the poster child for waste if you're just browsing.
It really is. The source really hammers this. A dedicated video card might have, 4 GB, 8 GB, even more, of its own special memory. Plus, a powerful graphics processing unit, the GPU, designed specifically to render complex 3D shapes for models or games.
But if you're doing online banking, reading the news, streaming a video...
You are using maybe maybe 1% of that card's capability, probably less. The average person is paying hundreds of dollars extra for this specialized piece of kit that is completely useless for their actual daily tasks. It just drives up the machine's cost significantly.
And the physical side effects of all this wasted power are things we actually experience. They're tangible annoyances.
Just basic physics, really. Thermodynamics. All that powerful, often idle hardware generates a lot of heat.
Which needs getting rid of.
Which needs active cooling. Fans spinning up, often really fast and loud. The cooling, in turn, uses more electricity. So you end up with this extensive machine that's also hot, noisy, and overly complex for tasks that could, theoretically, be done by something silent, cool, and incredibly simple.
Okay, so we clearly need a shift. This whole model was built when internet was, barely a thing. The source argues the whole philosophy needs to flip, right? Away from more, faster, more expensive, more complex.
Towards the exact opposite. Simplicity. We have to get rid of the complexity that causes all this maintenance grief.
There's a great metaphor the source uses about this.
Yeah, the car metaphor. We need to set things up so we spend maximum time driving the car, focusing on our actual tasks, getting things done, and a minimum time standing by the side of the road with the hood up, fiddling with settings, fixing problems, doing maintenance.
To really see the benefits of simplicity, we need to look back. Which brings us to Section 3. Learning from history, the thin client precedents. The source points to a couple of older models that actually embodied this centralized simplicity. Let's start with the mainframe.
Ah, the mainframe. The ultimate centralized system, really.
Right.
Used for decades by big companies, universities, governments. The software, the application package, was installed in only one place, on the big mainframe computer itself.
And all the thinking happened there.
All the heavy lifting, data processing, calculations, running the application logic, it all happened exclusively on the mainframe.
And what the user saw was pretty basic.
Famously basic. Users sat at what were called dumb terminals, just a screen and a keyboard. They did absolutely nothing except display whatever the mainframe calculated and sent to them.
So no local processing, no local software.
Zero local anything, basically.
Yeah.
No configuration needed on the desk. The management advantage was incredible. Need to update the main software. You did it once on the mainframe. Instantly, every single user saw the update. No need to visit hundreds of desks.
Incredible efficiency. Then there was a step forward, still simple though, the DOS Novell era.
Right. This was big in the 80s, early 90s. A move towards slightly more distributed processing, but still very centralized. The actual DOS applications like WordPerfect or Lotus 1-2-3.
Showing our age here.
Yes. They were still stored centrally, usually on a powerful server running Novell NetWare, a popular network operating system back then.
So users logged into the server to run the apps.
Exactly. They'd boot up their PC, log into the network, and run the software installed on the server. Their documents were usually saved back to the server, too.
But the PCs themselves, they were still pretty minimal, weren't they?
Incredibly lean. This is the key difference from the mainframe. The actual calculation, the data processing, happened locally on the user's PC. But often, those PCs didn't even have a hard drive.
No hard drive? How did they even start?
They might just boot up from a single floppy disk. All that floppy did was load the basic network software needed to connect to the Novell server. That was it.
So the admin simplicity was still there because the software and data were central.
Absolutely. Still centralized and secured on the server. If a user's PC broke, you just swapped it out for another basic terminal, plugged it in, they logged in, and bam, back to work instantly. All their stuff was on the server.
And the source has this really striking anecdote about the cost and effort difference between then and now. It really highlights the benefit of central management.
It's a great story. They mentioned working in a medium-sized company back in that Novell era. The entire system management for the whole network, software installs, user accounts, security, everything was basically done on the side.
That's a part-time task.
Almost. It took maybe 1 hour a week of focused work because everything important was in one place. Now compare that tiny effort, that low cost, with today's companies needing large, dedicated, expensive IT departments.
Teams of specialists.
Just to keep all these complex, individual fat clients patched, updated, and running smoothly. The historical lesson is crystal clear. Centralization means simplicity, stability, and radically lower running costs.
Okay, lesson learned from history. Simpler, centralized is better for management and cost. Let's fast forward. Section 4, the Cloud Computer Manifesto. We're moving towards that thin client idea, which we now generally call cloud computing.
Right. This is the modern term for that same core concept, and it's explicitly aimed at making computing cheaper, much, much simpler, and letting users just focus on their work, totally separating them from the tech headaches.
Okay. Here's where it gets really interesting, as you say. If we're designing the ideal future computer, the one that fixes all the fat client problems, what does it absolutely have to do? The source gives us this long list, over 20 essential properties. Let's break them down, starting with how it feels to use it, the user experience and stability.
Okay, user experience. The source is pretty demanding here. First off, the operating system itself. It needs to be practically invisible.
Invisible? How so?
You only see it as a sort of necessary evil that boots the machine and runs the browser. It shouldn't get in your way, demand your attention with pop-ups or updates. Just stay in the background.
And physically.
Utterly silent. Which is possible if you ditch the powerful local components, so no noisy fans needed. It must have a really long battery life. And it has to start up incredibly fast, like from off to a working browser in just a few seconds.
Okay, that sounds good. And crucially, it needs to fix that problem we all hate, the computer getting slower over time.
Yes, that's critical. Its speed must not decrease over time. This is a huge benefit of the thin client idea. Why do traditional PCs slow down?
Junk builds up, old files, registry clutter.
Exactly. Registry entries, bits of old programs, conflicting drivers, software bloat left behind by all those local installs. A thin client, running mostly from the cloud, using minimal local storage, just avoids that whole category of problem. It should stay feeling fresh, like it did out of the box, because its local footprint is tiny and doesn't really change.
And then something does go wrong, if there's a glitch.
It needs to recover instantly.
Yeah.
Updates should either be totally invisible to the user happening on the server side or just unnecessary because the main app lives online. And if disaster strikes locally, a bad update, a configuration mess up, maybe even a hardware fault, the machine must be self-healing.
Self-healing? How does that work?
Because the local state is minimal and ideally disposable. If the local setup gets corrupted, the thin client philosophy means you can just wipe that local profile. The machine then instantly downloads a fresh, clean, minimal image from the network, and boom, you're back up and running without losing any data. The user just sees maybe a quick reboot, not hours of repair work.
That sounds revolutionary compared to reinstalling Windows. Okay, that leads nicely into security and data integrity. This is where the cloud computer really changes the game, isn't it?
Absolutely. The security requirements are tough because the OS is so minimal, basically just running the browser, and because you're not installing complex applications locally.
The attack surface is smaller?
Dramatically smaller. The machine should just not be susceptible to the usual viruses, spyware, ransomware, all the malware that targets complex operating systems like Windows.
And what about your files, your data, the backup nightmare?
Gone. There should be no need for you, the user, to manually create local backups of your files.
Why not? That feels risky.
Because the requirement is that losing files and applications must be impossible, even if your device is stolen, destroyed in a fire, or the drive fails.
How is that possible?
Because everything important, yes, like your apps, your data, lives in the cloud, managed professionally. So if your physical computer is lost or broken, you just grab a new one, log in, and all your apps, all your files must be instantly available, exactly as you left them. That immediate recovery is the defining feature of a true thin client system.
Wow. Okay, now connectivity and accessibility. This is the whole point of the cloud, really.
Total freedom. The mantra is anywhere, anytime. You must have constant, seamless access to all your applications and all your files, no matter where you are or what device you happen to grab.
Because nothing important is stored on the device itself.
Exactly. It's all accessed via the cloud. This makes mobility effortless. You move between devices, locations, and your workspace just follows you.
And the device itself, the physical hardware, should reflect this total reliance on the network.
Yes. It needs to be mobile, obviously. You must connect easily, wirelessly, Wi-Fi, 3G, 4G, 5G, and have a wired option too. But here's the really radical bit from the source. The computer itself should have zero standalone functionality.
Meaning?
Meaning, without an internet connection, it's basically a brick, a paperweight, or its entire usefulness, its entire capability is determined purely by the network it's connected to. It's just an interface device, nothing more.
Okay, that's a strong statement. Finally, economics and openness. It has to be cheap, right?
It must be cheap, which should be achievable if you're stripping out all those expensive, power-hungry local components. We talked about the fast CPU, the big graphics card, large storage.
And the software side.
It should use open standards wherever possible.
Yeah.
Move away from closed, proprietary systems that lock you into one company's hardware or software world.
Like avoiding vendor lock-in.
Precisely. And ideally, the software you use should be free or very nearly free, preferably using open source models. So you combine cheap, simple hardware with free, open, cloud-based software. That's how you tackle the too expensive problem of the old fat client world.
This sounds amazing, almost utopian. But Section 5, the reality check. This isn't just theory, is it? This vision started becoming real quite a while ago. What was the first proper example of this cloud computer idea?
Yeah, it's not science fiction. The source points directly to the Samsung Series 5 netbook. It launched way back on June 24th, 2011.
The first Chromebook?
The very first modern Chromebook, yeah, running Google's Chrome OS. Basically just the Chrome browser as the interface. It was designed from the ground up as a pure cloud interface device. And the good news is the Chromebooks you can buy today, they actually deliver on nearly all of those properties we just listed.
Fast boot, quiet, simple.
Long battery life, low initial cost, stays fast over time. They tick most of the boxes.
So who are they actually good for? Right now, today?
Well, according to the source, they're potentially suitable for a huge chunk of the population. Maybe 90% of home users. Definitely students. The simplicity and mobility are perfect. Mobile workers whose job is mainly email, documents, web apps, and really anyone who just wants to get their work done reliably without fussing over the technology itself.
That's a lot of people. But clearly, they're not for everyone. Who is this cloud model not suitable for? Where are the limits?
The main limitation is still that heavy power user category. People who absolutely rely on very resource-intensive, specialized software that needs that constant high-speed local processing power.
Like who?
The source gives specific examples. Professionals using things like AutoCAD for complex engineering or architectural design. Or someone doing high-end, multi-layer image manipulation in Adobe Photoshop. Those are the users who still genuinely need the grunt of a local fat client machine. For now, anyway.
Okay, fair enough. Now let's talk about the iPad. It's often pushed, especially in schools, as the future of computing. Simple, app-based. But the source pretty strongly rejects the iPad for this role. Why? Isn't its simplicity exactly what we've been praising?
It's a really important point to clarify. Yes, the iPad is simple and approachable. But the source argues it fails on two fundamental requirements of the ideal cloud computer.
Okay, what are they?
First, it's a closed system. It's Apple's walled garden proprietary hardware, proprietary OS, App Store rules. That goes against the push for open standards and avoiding vendor lock-in.
And the second reason, this seems key.
The second and really crucial reason is that applications still have to be installed locally onto the iPad itself.
Ah, so it's still storing apps on the device.
Exactly. Every time a student downloads an app, it takes up space, it adds to the system's complexity, it needs local updates and management. That completely violates the core thin client principle of centralizing applications off the device. So the source argues, even though it's simpler, the iPad is still fundamentally a type of fat client, just a very streamlined one. It's not a pure network interface.
Got it. That makes sense. So even with devices like Chromebooks improving, cloud computing isn't perfect yet. What are the main drawbacks people face today?
There are three main ones currently. Number one, you are completely dependent on having an internet connection. Lose the internet, and you can do very little or maybe nothing at all.
Okay, that's a big one for some people.
Number two, web applications, while getting better, often still have fewer features and can feel generally slower or less responsive than their fully installed desktop counterparts.
The experience isn't always quite as slick.
Not always, no. And number three, not every standard desktop program that people rely on has a really good, full-featured web version available yet. There are still gaps.
Right, so limitations are real, but the source sees a way forward, doesn't it? Something that's going to fix these issues.
Yes, and the key is HTML5, the newer standard for building web pages and web applications. It's seen as the technology that will dissolve these disadvantages over time.
How? What does HTML5 actually do to help, especially with that offline problem?
Okay, so HTML5 isn't just about making websites look fancier. It includes specific technologies designed for more powerful web applications. Things like web storage and application caching.
What do they allow?
Previously, if you were working in a web app and your internet dropped, that was it. Session gone, maybe work lost. HTML5 lets web applications store significant amounts of data securely locally within the browser's private space.
So you can keep working.
Exactly. You can keep editing your document, drafting your email, whatever. The app saves the changes locally. Then, when your internet connection comes back, it automatically syncs those local changes back up to the cloud seamlessly. It dramatically reduces that need for a constant connection.
Okay, that's huge. What about the speed and features gap?
HTML5 also allows web apps to tap into your computer's hardware much more effectively, using graphics acceleration, for example. This means web applications can become much faster, much more responsive, and visually look and feel almost identical to traditional installed desktop software. The performance gap should virtually disappear.
So the conclusion here is, yes, there are drawbacks now, but they look like temporary technical hurdles.
That's the argument. There are problems that the natural evolution of web standards, specifically HTML5, is rapidly fixing. The tech is catching up with the thin client vision.
All right, let's tackle the big one. Section 6. Data security. Why the cloud is safer than your home. This is probably the biggest mental block for people, right? Handing over control of their data.
It's totally understandable. We all hear the scary stories about big data breaches, potential government spying. The idea of your personal stuff being stored out there somewhere, not on your own drive, feels inherently risky.
But the source pushes back on this fear.
Immediately. Yeah. They put it into perspective. Think about it. Many of us have been storing really important communications. Personal emails, work emails in the cloud for, 15, 20 years?
Yeah.
Hotmail, Yahoo Mail, Gmail.
Right, long before we called it the cloud.
Exactly.
Yeah.
And there wasn't the same level of widespread panic about safety back then, even though the principle was the same.
And we need to compare apples to apples, right? The security of Google or Microsoft versus me at home.
That's the pragmatic argument. You're comparing the security efforts of an average home user who's busy with their life, not cybersecurity, against a massive global company like Google or Amazon or Microsoft. These companies employ thousands of the world's absolute best security experts.
They have huge budgets for this stuff.
Billions invested in cyber defense, multiple layers of redundancy, encryption protocols far beyond what any individual could implement at home. So the source argues the actual danger, statistically, is far more likely to come from you, the end user, making a mistake, than from a fundamental breach at a major cloud provider.
So if we use the cloud, the responsibility for security partly shifts to us. We need good habits.
Absolutely critical. The source highlights 3 pillars of user safety that are just non-negotiable if you embrace the cloud.
Okay, what are they?
1, use strong passwords. Long, complex, unique for every important service. 2, change those passwords regularly. Use a password manager to make this easy, something most people still don't do properly.
And the third.
3, use two-factor authentication, or 2FA, everywhere it's offered. That extra code from your phone or an app provides a vital extra security layer. If you practice this basic security discipline, the argument is your data is significantly safer in the professionally managed cloud than sitting on your vulnerable home computer.
And to really drive this home, the source uses this incredibly powerful, relatable story comparing cloud email to locally stored Outlook email. Let's dig into why that local storage was so prone to disaster.
Oh, this anecdote resonates with anyone who's worked in IT support.
Yeah.
The author makes a striking claim. In their entire 30-plus year career, they have never met anyone who permanently lost their entire collection of Gmail or Hotmail messages. The whole archive, just gone.
Because it's backed up, redundant in the cloud?
Exactly. But, they say, they have met countless people who lost everything, years, sometimes decades worth of locally stored Outlook emails. Tens of thousands of messages gone in an instant.
Because of the dreaded Outlook PST file failure. What exactly is the PST file and why is it so fragile?
Right, the PST, or personal storage table. It's basically one single, enormous database file that Outlook uses to store absolutely everything locally on your hard drive, all your emails, folders, contacts, calendar appointments, tasks, everything crammed into one file.
One single file holds it all.
Yes, and because it's this single massive file that's being constantly read from and written to whenever Outlook is open, it's notoriously fragile. If your computer crashes suddenly while Outlook is writing to it, if you have a power surge, or even if the file just grows too large over the years, it can very easily become corrupted.
And corruption means?
Often means total data loss. The file becomes unreadable. Suddenly, years of vital correspondence, attachments, contacts, just gone. And that nightmare scenario is inevitably followed by that heartbreaking question the IT person always hears. Backing up. Oh, was I supposed to be doing that?
Wow, that really brings the risk home. It perfectly highlights the difference. Local storage creates these single points of catastrophic failure,
which professional cloud systems are specifically engineered to prevent through massive redundancy and distributed backups. So the final conclusion on data from the source is really clear. Storing your data in the cloud, assuming you use strong passwords in 2FA, dramatically minimizes the risk of losing it all compared to relying on local storage like your physical hard drive, which will eventually fail. It's just a matter of when or easily lost or damaged things like USB sticks. The convenience of anywhere, anytime access actually comes paired with much better, professionally managed data safety.
Okay, this has been a fascinating deep dive. We've covered a lot of ground. What's the ultimate takeaway message, the core philosophy we should carry forward from all this?
I think the core philosophy boils down to this. Work as much as you possibly can in the cloud. Really lean into that anywhere, anytime, any device principle. The real beauty of this model, when it works well, is that the only things that truly matter are having a decent web browser and a reliable internet connection, the specific device you're using. It almost becomes irrelevant. The underlying technology fades into the background.
So it's basically the case principle, isn't it? Keep it simple.
Exactly. Keep it simple. If you embrace this cloud-centric model, and crucially, practice that good security discipline we talked about,
Strong passwords, 2FA.
then you really can just focus entirely on your tasks, on what you want to achieve, and pretty much ignore the technology underneath. Never worry about updates, backups, or hardware failures wiping you out again.
So thinking about you, the listener, what this really means is if your current computer suddenly dies or your laptop gets stolen or you drop your phone,
Right.
you avoid that absolutely devastating loss of years of photos, crucial emails, important documents that might be stored only locally right now because the data itself remains safe in the cloud, ready and waiting. You just log in on a new device and it's all instantly there.
It's an incredibly powerful shift in thinking. It really strips the computer down to its absolute essence, just an interface to the network. Which leaves us with one final kind of provocative thought from the source material.
Oh.
Well, if the ideal future computer, as defined by all these properties, gets its entire functionality purely from its internet connection, if the hardware itself truly has zero standalone capability, does the computer as a distinct device even exist anymore in the way we think of it now?
Or does it just become a window, a screen onto the network itself?
Exactly. Does the device disappear conceptually, becoming merely an access point for network services?